You would think that a simple insect with a tiny brain and a very simple nervous system would not be much more than a very simplistic, almost automation or robot. And yet, they're capable of very complex behavior. They can learn. They're fascinating in their senses they have. You can study memory effects, orientation effects. They solve problems, all kinds of things that you would never think, or at least I would never have thought that a simple insect system could do, and they do it collectively. It's basic Pavlovian conditioning, the same way you train a dog or a porpoise or a seal or a whale. Same type of operating conditioning or training that is used for these other organisms applies to bees also. And the one reward that drives them is syrup, free food.
This whole system is set up to do is to mimic some sort of weird flower. What we do is take advantage of bee behavior by tricking them into thinking that here's a flower that has a very rich reward, has a very peculiar scent. And they can land, they can walk around, and if you watch, they're busy probing with their little proboscis trying to find the best source of nectar, just like they would on a flower. So we've got our flower here, we've got a ring here, that's the scent. Ring. Then in the center is the nectary. Nectaries tend to be in the center of the flowers. Bees will fly over the fragrance areas and into the nectary. It's just a weird pseudo flower. The scent that we're using for this case, we're trying to find explosives. One of the strongest contaminants and breakdown products of explosives is a component called 2,4-DNT, 2,4-dinitrotoluene. It's not explosive, it's classified a poison, but it vaporizes, it bleeds through plastic, it disperses through the soil and produces a vapor plume above the place where the explosive is contained that the bees very quickly condition to and associate with the sugar reward. This is our control sample. What we've got is a little bit of DNT, and it's going to produce a vapor plume and no reward, and we're going to see if insects, bees in fact, will come to it. There's one out there. I just catch glimpses of her. Here she comes. Oh, she's in a hurry. Following, following, following. Here comes one right behind her. And she made it, accompanied by a friend.
So we're going to scan the laser beam side to side in the minefield behind me here. So we're going to be looking back and forth, with the idea being that we're looking for peaks of bee density, basically any kind of bee clustering over time.
But take it not, huh?
Depends on which section you go to. We went up way high. What did you guys do, like East Fork, West Fork? Almost. We went to Blackson. It's not too bad. It's still a little bad.
This must be it because it's got scratch marks.